contents in this video are introduction, problem statement, problem solution, and conclusion. First of all, I will explain the meaning of differentiation and why differentiation matters. So, what is differentiation? Differentiation is the process of finding the derivative of a function, which measures the exact rate at which one variable changes in response to another. Geometrically, it calculates the gradient or slope of a curve at any given point. And so, why differentiation matters? In physics, it predicts motion like velocity and acceleration. In economics, it is to find marginal cost and revenues. In biology, it is to modeling growth and decay. While in optimization, it is to locate exact minimum and maximum in system.
What are the techniques of differentiation? Okay, let's take a look for the basic differentiation rule first. For the first one is the constant rule. Second, linear rule. This is the sum rule formula and the difference rule formula. This is formula for the product rule. C, quotient rule. D, chain rule. Okay, E, implicit differentiation. Implicit differentiation is a calculus technique used to find the derivative dy over dx of an equation where x and y are intertwined. The F, exponential and logarithmic differentiation. Okay, G, differentiation of trigonometry function.
For this question, I use the chain rule because there is a function inside another function. First, I let t equal to 3 x square root minus 5x plus 1. Therefore, y becomes t to the power of 4. Next, I use the power rule to differentiate t with respect to s. So, dy over dt is equal to 4t to the power of 3. Second, I find dt over ds by let t equal to 3x square root minus 5x plus 1. Next, I multiplied 2 by 3 and the power decreased from 2 to 1, so the derivative is 6x. By using the same method, the derivative of negative 5 is negative 5. And the derivative of 1 is 0. So dt over dx equal to 6x minus 5. Then I apply the chain rule by multiplying dy over dt and dt over dx. This gives 4t to the power of 3, 6x minus 5. Lastly, we have to substitute t back with 3x square root minus 5x plus 1. So dy over dx equal to 4 times 3x square root minus 5x plus 1 to the power of 3 multiplied by 6x minus 5. That's the answer for this question.
The function consists of polynomial equation, which is 2x to the power of 2 minus 3x plus 1, and exponential function, which is e to the power of x to the power of 2. Since these two functions are multiplied together, I will be using the product rule. So first, we must separate the functions so it's easier for us to solve. So u equal to 2x to the power of 2 minus 3x plus 1, and v equal to e to the power of x to the power of 2. Next, I will be differentiating each function separately. For the polynomial function, I will be using the power rule. And for the second function, which is exponential function, I will use the chain rule. We use the chain rule for the second function because the exponent x to the power of 2 depends on x. So we differentiate the outside first, then multiply by 2x. First, separate the outer function and the inner function, and then differentiate those two functions separately. After that, using the chain rule, multiply these derivatives together. After that, substitute the derivatives into the product rule formula, which is dy dx equal to u multiplied with v prime plus u prime multiplied with v. After substituting the derivatives into the product rule formula, expand and simplify the expressions.
First of all, we must apply the equation in chain rule first. So dy over dx equals to 1 over u multiplied du over dx. Okay, then we just need to flip the u fraction. So x minus 3 at the top over x squared plus 1 at the bottom. Alright, this is the Gaussian rule formula. Okay, I assume that x squared plus 1 over x minus 3 is our u. So now we can differentiate u using the Gaussian rule. So f equals to x squared plus 1, f prime equals to 2x. Okay, to get f prime, we need to differentiate x squared plus 1 first. G equals to x minus 3, g prime equals to 1. Alright, let's plug this into the Gaussian rule formula. Okay, this is after we plug all of those into the Gaussian rule formula. Okay, now let's expand and simplify. Then we can substitute both parts back into our main chain rule formula. 1 over u multiplied du over dx. Okay, 1 over u equals to x minus 3 over x squared minus 1. Okay, multiply with du over dx equals to 2x squared minus 6x minus x squared minus 1 over x minus 3 squared. After that, we can cancel out one factor of x minus 3 from the top of the first fraction and the bottom of the second fraction. Okay, so this is the final simplification. dy over dx equals to x squared minus 6x minus 1 over x squared minus 1 x minus 3. Okay, that is the final answer. Okay, that's all from me. Thank you.
Here is our function. At first glance, we have a fraction, and we have a function inside another function. To conquer this, we need to use the quotient rule and chain rule. Step 1 is to identify our component. We label the numerator as u and the denominator as v. Now, step 2. Find derivative for the numerator u. We use the chain rule. We know the identity for tangent is secant squared. So now we got u prime is equal to secant squared x squared. After that, we multiply the derivative inside x squared. That gives us 2x secant squared x squared. Next, we use power rule for the denominator v. We rewrite the square root as an exponent and apply the power rule to get 1 over 2 times of the square root of x. Step 3. Apply the quotient rule. Now we have u prime, v and v prime. We can load them into our quotient rule formula. Next, step 4. We simplify. To fit the fraction inside another fraction, we multiply the entire numerator and the entire denominator by 2 times the square root of x. Now, let's look closely at what happens to our denominator. We started with 2 times x and we multiply it by the square root of x. To make sense of this, we change everything into exponent form. The x has an invisible power of 1. So 1 plus 1 over 2 halves is equal to 3 halves. After we multiply all this, we got 4x squared secant squared of x squared minus tangent of x squared divided by 2x to the power of 3 over 2.
Okay, for the conclusion, differentiation is a calculus method for calculating a function's rate of change. The technique of differentiation is a specific method used to find the derivative of a function. There is core operation that known as mastery rule. For instance, power rule, product rule, quotient rule, and chain rule. Differentiation also helps us to find the slopes and tangent lines. In addition, solving real-world economic problems to optimize profit and cost. Lastly, simplifies complex curves.
That's all for our presentation on techniques of differentiation in Maths 186 Calculus 1. Thank you for watching, and we hope this video helped you understand the topic better.